Welcome back to another tutor training. This one is all about polynomials. We're going to split this up into two videos. The first about just exponents and their rules, and the second about adding, subtracting, and multiplying polynomials. First, let's talk about this table. I'm going to fill it out, and there's going to be one similar to it on your assignment for this video. You'll see the name of the rule on the left, and what I'm going to call the book rule right there. In this column, you're going to see abstract variables, which can be very confusing for a lot of math students who aren't used to things that are written abstractly with all of the variables. It can be overwhelming and confusing, and so we're going to focus on the examples. And as a tutor, it's going to be great for you to focus on examples as well to help students understand the rule, why it works, and how to implement it in their homework. So we're going to have both in the chart, but know that examples are going to be the most helpful for you when you're teaching. We're going to start first with product rule and quotient rule. Product meaning multiply, so this has to deal with multiplication, and quotient meaning divide, so we'll look at that. Let's look at an example, and I'm going to expand these examples to help explain why the rule works. So let's start with 2 to the third power times 2 to the second power. Order of operations says we multiply after we do exponents, so we're going to exponent that, and we get 8 times 4. Okay, cool. Answer is 32. But there is a different type of shortcut. If we expand each of those, we have 2 to the third power is 2 times itself 3 times, and then 2 to the second power is 2 more 2s. So in total, we have 5 2s. You plug that in the calculator, 2 to the fifth is actually 32. Another way to think about it. And so when you add, in our book column over here, it says we add the exponents. We're just counting up the total number of bases. So if we have x to the, let's say 12th times x to the 5th, in total we have x to the 17th. And we don't have to write out all 17 x's. We just add 12 plus 5, that gets us 17. Notice for this rule and the next one, you have to have the same base. Alright, so if it was x and y, or 2 and 3, I can't add the exponents like that. Okay, quotient rule. Quotient meaning divide. Let's look at an example. Let's do 3's this time. So 3 to the 4th power over 3 to the 2nd power. Order of operations, again, would say that we'd multiply that out, get 81 and 9. Okay, cool, 9 is my answer. But if I write those out, expanded, like I did with the 2's, there are 4 3's there, and 2 3's here. 3 divided by 3 makes this a 1. You'll hear people say that it cancels, but really it just becomes 1. So we have 1 times 1 times 3 times 3. We have 3's left, 2 3's left on top. So we have 3 to the 2nd power. So the shortcut on this one, in our book rule, it says to subtract. If we're dividing, again, with the same base, let's write that over here so I don't forget, same base, then we can subtract the exponents. So with a variable, we could do something like x to the 125th, I'm not going to write all of those, over x to the 32nd, we can just subtract those and get x to the 93rd, right, minus those. Now, one thing to be careful of, we'll talk about this with the negatives as well. It is okay if we have, right over here, a smaller exponent on the top. Right, we get x to the -5th. That is okay. All right, let's move on to 0 and negatives. Here's our, my examples went away. Here's our next two rules. The first one says anything to the 0 power is 1. We actually talked about that in the scientific notation video last week, and so let's just remind ourselves of some examples of that. My favorite number, maybe it's yours, pi to the 0 power is 1. Any number to the 0 power is 1. Some students might get confused and say that it's 0, or that it's that number itself. Right? They might say 5 to the 0 is 5 or 0, but it is 1. Okay, we also talked about negatives last week in the scientific notation video, and so if we have negatives, then remember that means instead of multiplying, getting the bigger number, we're going to divide and get small numbers. or fractions. Doesn't give you negatives, right? That's another common confusion. It doesn't give you a negative. So if we have, say, x to the negative 3, that's really 1 over x to the third, or maybe we have 2 to the negative 4. That's 1 over 2 to the fourth, which is 16. Now, the second part of this rule, in the book rule part, is that if I have a negative on the bottom, it goes to the top. And so if you look at this, if we have 1 over 2 to the negative fourth, that'd be 1 over 1 over 16, which, right, cube change flip, if we change that, it would flip to the top, and this would be 16, or 16 over 1. Okay. I had ATA, I'm just going to go ahead and write down here because I have enough room, who called negative exponents elevators. Oh, I didn't finish writing that word. Elevator exponents. So one way to help your students remember if they get confused with the negative exponents is that if they have a negative on the bottom, like x to the negative 3, then it's going to come up to the top, get off the elevator, and become positive because it's so happy to get off the elevator. It's just changing floors. Maybe you have y to the negative 5th on the top. It's going to get on the elevator and get off on the positive floor. It's so happy to not be on that elevator anymore. But that only happens with negative exponents. If it has a positive exponent, it does not move or change. Okay, the next 3 all have to deal with parentheses. So I just call these parentheses rules. If you have an exponent on the inside of parentheses, the power rule will start there. So let's say we have x to the third to the second power. So that means we have x to the third times itself twice. Okay, product rule says we add those together, you get x to the 6th. So the shortcut on this one is to multiply those exponents. So if I have, even with negatives, I have negative 5 to the negative 3, that's going to multiply and get x to the positive 15th. Okay, power of a product means there's multiplication happening inside and an exponent happening on the outside of the parentheses. So let's say I have, let's do whole numbers first. 2 times 30 to the third power. Okay. Order of operations, parentheses first. 2 times 3, that's 6 to the third power, or 216. But what this rule is saying is I can distribute the exponent a little bit differently than we usually think about distribution. To be 2 to the third times 3 to the third. 2 to the third is 8. 3 to the third is 27, which of course equals 216, so it works either way. The nice thing, of course, is when you have variables, let's say if I have 2x to the second and y to the 5th, and now here I have 2. That means everything inside gets that exponent just like Oprah would want it. You get an exponent, you get an exponent, and you get an exponent. So 2 to the second, x to the, remembering the last rule, 2 times 2 is 4, x to the fourth, and 5 times 2 is 10. Simplifying that, 4, x to the fourth, y to the 10th. Last one, power of a quotient, means of course that we have a quotient inside the parentheses and an exponent on the outside, so we're dividing again. This always helps me to think about it as a fraction. That's why I've written it this way. And so imagine you have 2 over 7 to the third power. If we expand that, as we have been doing, I'm just multiplying that fraction by itself 3 times. So I get on top 2 times itself 3 times, and 7 times itself 3 times. And so what this one says, of course, is that you can distribute that exponent to both the top and the bottom. Everything on top, everything on bottom. So we have 8, going me to finish that, over 343. But if we have more variables in there, let's try 2x to the 5th over y to the everything all to the negative 2. So we're going to distribute that here. That's 2 to the negative 2. X to the 5 times negative 2 is negative 10 over y to the negative 2 is y to the negative 2. Okay. And then, oh, look at all those elevators. We're going to take 2 to the negative 2. We're going to bring that down. It's going to be 2 to the positive 2, aka 4. And then y to the negative 2 is going to go up. And x to the 10th is going to come down. And then they become positive. Ta-da! Okay, I want you to try and apply these rules on these two problems. Notice we just did that part. You're welcome on the last screen. So try out both problems and then unpause the video and see how you did. Okay, I'm going to try these out. I'm going to multiply these first. I'm going to multiply the ones that are not variables. That always helps. Those are nice. And then I'm going to have a product rule here, so I'm going to add that. There's a little invisible 1 right there. 3 plus 1 is 4. And then my p variable here, 2 plus 10, is 12. So just negative 8x to the 4th p to the 12th. All right, number 2, I'm going to distribute this 3 to everything inside, top and bottom. That's going to be 2 to the 3rd power, x to the 6th power, and y to the 12th power. And we already simplified this other one from the last screen, so let me just jump ahead. It was y squared over 4x to the 10th. All right, 2 to the negative 2 comes down, becomes positive 4. X to the negative 10 comes down, becomes x to the 10th. And negative 2 times y to the 1st power is y to the 2nd on top. All right, so let's simplify what we have. 8x to the 6th. Y to the 12th. I'm just going to put these on the same fraction so that we can combine the ones that are alike. One thing that helps students a lot is to group things that are alike together. So I'm going to put just the constants. I'm going to put the x values. And I'm just going to deal with one at a time. Okay. 8 divided by 4 is 2. Okay, no negative exponents, so it's just 2 on the top of the fraction there. I'm going to subtract the rate. This is a quotient, so I'm going to subtract the exponents. X minus 10 is x to the negative 4, which means it will take a little trip on the elevator, come down, and become x to the 4th. Okay, 2 minus 12 for my y variable is going to be y to the negative 10, which of course is going to take a little trip down on the elevator to be y to the 10th. While we're here with the quotient rule, some students prefer to think about it this way, is they'll say, okay, 6 of these cancel with 6 of these, and I'm left with 4. That's another way to think about it. Instead of subtraction, you can help them out either way. Okay, that's exponent properties. Go ahead and watch the next video about polynomial operations.